I'm Ben Poise. I'm the product manager for Android Framework. I like how everybody's right over there. I wish I could join you. The sun's going to come and get me. What I want to talk to you guys about is background limits and a lot of the infrastructure that we've put in place in O. And it's a starting point. And I wanted to try and have this talk give you a glimpse as to how we're approaching the problem. And so you don't just think we're trying to ruin all the apps and everything you're doing in the background. We're actually trying to find a balance of enabling users to have battery life they can rely on, and enabling developers to do the use cases that they think are great and that users respond positively to. And so to do that, we're going to talk a little bit about the past, a lot about the present, and then a bit about the future, where for one of the few times we're going to give you a glimpse of the space that we're trying to go longer term. So in the past, we have doze and standby. Doze and doze light were introduced to try and save battery in two main conditions. One being when the device is off for a long period of time. So a good example of this is I take my tablet, I toss it in my desk, and it sits there for a few days. In that, you really want the device to last a long time, and doze was introduced to make that device last up to a week. And it was largely successful when it was introduced. Doze light was trying to take that same concept and apply that to my phone is in my pocket, it's not on, but it is on me. And doze wasn't identifying that situation, and doze light was trying to target that and to start slowing down applications and limiting what's happening throughout the day. And app standby was very similar in concept, but then about is the user interacting with the application very often, and if not, begin throttling that back. We also looked at broadcast removal. And this was when we targeted an initial set of 3 particular broadcasts. And the best example of this was, we were finding you take a photo, and suddenly all the applications are getting really excited about that photo because they're listening to that broadcast. And they would all be waking up and going, what's going on with the photo? Is there a restaurant nearby? Should I back it up? What should happen? And the user's going, I'm really just trying to take a photo. God forbid you're trying to take 2 photos, because the first photo triggered everybody to wake up, and the second photo is now this resource contention. And so we found this was really successful to pull these guys back from being these general broadcasts and instead being a bit more targeted. And so that's kind of like the lead-in to then the present, where we started looking at then a general strategy for background limits. I'll also talk about alert window as well, which has a very similar problem space. And then a bit about how we're trying to bring a data-based approach to improving system health on Android. I don't mean health like my personal health, but more like the device health. And then I'll pepper in a few best practices as we go through. So background limits, why? So what we're trying to do is 2 parts. One is to save battery. This one was largely around the limits that we put in place for location. And the goal that we're trying to get at is we want multi-day battery life. It's going to take us a while to get there, but that's where we're trying to go. And to do that, we know we have a pretty large task in terms of what's happening in the background. It's a nearly 6 to 8% efficiency improvement from where we are today. And so that's like the backdrop, if you will, of how we're thinking about it. And these are the kind of initial steps in setting the framework for how we're going to get there. The other part is about RAM management and working on how broadcasts are being fired to applications, and also dealing with how applications are running in the background with long-running services. So just to give you a concrete example of this, is you have this chart of screen-off performance over time. And the one thing you can see up here, I can't see my monitors anymore. The sun has totally killed me up here. But the one thing you can see up there is over time, you're going to have a slide of your screen-off battery performance the longer the phone is in the field. You'll also see that the jank rates, or slow UI frames, get higher the longer the device is in the field. And so these are things that we really want to help remedy and add robustness into the platform so we can really smooth these out. Obviously, over time, devices age and physics comes into play and the march of time happens, but we really don't want them to be anywhere near that steep. Another example of this is as a device is on, in the course of even days, this one's measured all in initially hours and then in days, you can see just uptime starts to take a toll on the device. And so these are the things that we're really trying to target and to improve. So let's dig in a little bit to some of the changes that we're introducing. Background limits, and on the save RAM part, is we want to restrict services and broadcasts, and we want to reduce the amount of churn that's happening on the device. And the save battery, we're looking to improve background location scan rates and Wi-Fi scan rates, and to reduce them and make them be more of a trickle than these really bursty events that we're seeing happening in the ecosystem. So for background limits, the big one here is we want to reduce that RAM usage. And to do that is, well, this slide's like the same. I should just skip. So how we're doing that is with broadcast receivers. By pulling these guys back, you're able to then say, OK, all these broadcasts before that were implicit in waking up applications are going to be silenced. If you're running at the moment, you're still going to get them. But if you're not currently running, we're not going to wake you up for them, except in the case where they're explicit. In explicit ones, we say something really important has happened, or you've been targeted, or you've registered for some wake up, and those things will still work completely as normal as they did before. And so that follows like alarms and notifications. Other ones that we're still keeping around, boot completed, locale changing, and these are really events that are not happening as the user's trying to do something else. And that's really been the target of how we approach which things should continue to work and which things should we start deferring. The other one here is free-running background services should no longer be a thing. And the idea behind that is we want users to have visibility to what's happening on their phone. And so if an application is doing something really expensive in the background, we want there to be some awareness for the user. We don't want the device to be toiling away in the background without any awareness. This also means we want to then start stopping those services after they're running for a little bit. We want to start throwing, we're going to start throwing an exception if you start a background service when you're not in the foreground or when you don't have a foreground service running. And this is also the very last one is we'll start releasing wake locks under some more conditions. You still want to manage your wake locks. Don't think the OS is going to handle it for you, but we are adding more protections in different scenarios where they might have been leaked or the developer was a little lax in their cleanup. We still have the whitelisting strategy that we had before, so there will still be a whitelisting strategy that is around when GCM fires off a broadcast to your application. You'll still get woken up. You'll get a short exemption to handle that message. From there, you can kick off a service. You could bring your application to the foreground if it's appropriate. Or you can just take a note, run it, schedule a job or alarm, and have it be scheduled by the OS and happen when it happens. There's also the flexibility still for OEMs. If you're relying on some OEM-specific intent or something behavior that's not built into AOSP, Android open source, the OEM will be able to define on their own which things are explicit, which things are implicit, and should still be fired, and which things are implicit and should still get the brakes tapped on them. So you might be thinking at this point, like, this all, I guess the user part of my brain is really, really happy, probably. The developer side's going, wait, I have things to do. I have things to say. How can I communicate to the developer? Like, it's really important, Ben. What are you doing? And so there's a number of strategies, and I'll talk about them right now, of how to do these operations still with the user on a timely basis and still be respectful of the battery, but then also be able to tell the user, no, I'm doing something incredibly important. So the first one to look at is using Firebase and Google Cloud Messaging, and using the high priority and normal priority messages. I hope your takeaway from this slide is not like fire all torpedoes at high priority. We really want you to be kind of balanced in saying, if something is important, like say my fire alarm is going off at home and I want to send a notification to the user, use a high priority notification. It's kind of a big deal. If you're, say, using the user's scheduled for a TV show that they like, and that TV show is now available, and they can stream it at their leisure, use a normal priority notification. And it'll make a big difference in the battery life of the device, and it really adds up when the ecosystem starts taking these approaches. The other one here is something new. It's called the Job Intent Service. And this is coming out. We just missed the window, but I still wanted to talk about it for what came out with the new 26 beta. But it will be coming out shortly before O launch. And it's a strategy of you can use Job Intent Service on O to give you backwards compat support so that you will use then jobs when you're on O, and you'll have an automatic fallback to using services pre-O. The really nice part about this when you have that fallback is we'll handle the wake locks for you. So you don't have to worry about, are you going to make a leak or make a mistake there. So definitely take a look at this when it comes out. It's going to make your lives a lot easier to adopt. The other last one here is about alarms, syncs, and job scheduling. These are all good strategies to run jobs on a cadence in the background that gives the OS flexibility about when it runs. So to give you an example, if all these applications before, when we had a world of these broadcasts being fired and that applications could start services, they'll all start at the same time. And the OS really has only nukes to deal with this problem. We can only kill your process. There's no ability to throttle. We can't try to squish RAM. It's just you live or you die. And when RAM becomes contentious, we start thrashing pretty rapidly. When you're using jobs and alarms, the OS has now flexibility to defer, to run one job at a time, a few jobs at a time, and spread it out across the lifetime of the device. And that avoids then resource contention. It avoids janky UI in the foreground because stuff is happening in the background. So I've made this really exciting flowchart for you that you can look at later. But the idea behind it is roughly looking at what are the different stages that are happening and what is the right choice for you as a developer and for the user to have like the best, most efficient experience for the use case that you're trying to achieve. Yes, the end of this is maybe you shouldn't do it in the background. And that's the one I really want you to focus on, is think about, do I really have to be doing this? Is the user going to understand what I'm trying to do? If the user is going to understand what you're trying to do, and a great example of this are like navigation apps, music playing apps, various exercise applications, all of those scenarios, if you're running a foreground service and the user sees a notification, it's going to make sense to them. You're going to be really well aligned. So in those scenarios, please go do that. In other ones where you're like, I don't know how to explain this to a user, then you should definitely be considering jobs or just be considering not running it in the background at all. So transitioning, that was the battery saving and executions portion. And now we're going to transition a little bit to talk about location limits. And the idea here was to put some upper bounds on what we're seeing happening in the background around geofencing, polling, and others. And it was causing really a significant amount of drain. And the reason is location is power hungry. And there were really no functional limits on what an application could do when it's in the background with respect to location. And so it would end up with two different types of scenarios. We'd have, and most of them, to be honest, are accidental. One being is that applications are aggressively requesting location. And this could be because they're interested in where you are or they have a particular use case. But the one that was really sad was this idea of leaks, is that if you're running in the foreground, say you're navigating, you're going to have a really high rate of query. And when you go to the background, that high rate maybe isn't necessary anymore. And the intention of the developer was to reduce it. But for one reason or another, similar memory leaks or wake clock leaks, it's still running full blast. And that we saw a lot of applications polling at once every second, getting a location request. And that's just going to completely destroy battery. And so those are the two areas we're trying to target here. So the idea now is not to say that you can't run in the background, because we're still enabling that. But the idea is to space it out. Once every 30 minutes with a cycle of accuracy of 2 to 3 minutes within those 30-minute updates. So you can think of it as you have a 30-minute delay, roughly, within an update accuracy of 2 to 3 minutes within that 30-minute cycle. The same thing will apply with Wi-Fi. The API is a little bit different. We don't have the kind of convenience for scheduling. But the idea is if you're banging on the Wi-Fi scanning query, you'll keep getting the same results if you're going too fast. We won't actually do the query. And so those are the two strategies that we've taken for location and for Wi-Fi. So just to highlight, there's a number of options here that are lower battery impacting that you should be looking at. One is batching, geofencing, and in the complete last case, again, is to consider the foreground service. If you are using the foreground service and the user understands what's happening, that's really kind of critical. But if they understand what's happening, that will then enable them to say, oh, OK, yeah, you're running in the background, you're expensive, I get it, moving on. And you'll have relaxed requirements when you're in that mode. So the other thing I wanted to take a moment, I know it feels like a lot about battery, and then suddenly I'm talking about alert window, but I want to take a moment to talk about it, is there's a number of use cases that this is coming up with. And to be brutally honest with you, this was only intended for what the name is, system alert windows. It was never really consciously intended to be used the way that it has been. But we were in a simpler world in API 1, and it was left public, and people have found really amazing ideas and solutions using this API. And so we don't want to get rid of it. However, we do want to try and put it on Rails. What we're really worried about is many applications rendering on top of each other, conflicting with each other. There's no attribution of what applications happen to be rendering at any point in time. And so the idea was that can we add some layering? Can we add some attribution within the model? And that's what we did with the application overlay. And so the idea here is, with an app overlay, is the user can now manage what is floating above their application activity. It's Z-ordered properly unto themselves and to system UI and to the application below. And then we'll automatically show a foreground notification in the notification menu so the user is aware if there are multiple applications simultaneously using this feature. This way, if they see it, they're unhappy with it, they can go to the application, control the settings if they want. You should always make sure your users are aware of using this because it can be kind of surprising if it doesn't happen. And the other thing that we changed was for targeting on O is if you are now using this new overlay type, you will then sit above the legacy views. So this is maybe your incentive to adopt a new model, is once you're using that, everybody will be properly Z-ordered in a kind of LRU fashion. And then you'll sit below system UI, but above things like the keyboard and other system UI components. So now I want to transition a little bit about talking about how we're going to improve the system with data. And I don't mean to blame anyone, because it's not. That's not my intent. But it's really a story about applications, and that phones are amazing, and you can do so many things with this portable computing device. However, we have resource scarcity, mostly in the frame of battery. And the question then comes up, well, then how do we balance this? And the big thing that we've realized, and you might be thinking at your seat like, yeah, no duh, thanks. But there really isn't great tooling up until very recently to help developers understand their impact. And when we reached out even internally at Google, we would find they didn't realize they were doing it. And so that kind of brought about a number of thoughts that I'll get into in a moment. And the other one is this kind of tragedy of the commons, in that you have so many applications on your phone, and if any of those applications say stick a wake lock, you only need one to do it, and the cost is now your CPU is unable to go to sleep, and you'll have a very precipitous drain on your battery over time. And when you have hundreds of apps, and only one needs to make a mistake, you're pretty much guaranteed to have a bad time. And so what we started looking at is how can we get to a point of sustaining performance, introducing accurate measurements for developers, and bringing online new dashboards. So let's dig in a little bit into what these are. And there's a talk on bad behaviors. It was earlier in the day. If you haven't seen it, please go hop on YouTube and go take a look at it. It's very, very good. The guys that presented it are right here in front, staring at me. So it's good. Thank you. But the big one here is we're looking for egregious behavior that we can all agree on. And so a good example of this is wake locks. Is if you ask a developer, you were holding a wake lock for 6 hours straight. You weren't in the foreground, and the user wasn't interacting with your application. And pretty much everybody says, yeah, I shouldn't have been doing that. And so the trick, though, is there wasn't really good instrumentation to help you understand that was happening. And that's where the Play Console is coming into its own and bringing out these features, so you can now see these type of situations that are happening. Other big one has been really severely janking frames, so frozen frames. Frames take over 700 milliseconds to run. Also really hard to figure out where in your application they're occurring, and even if they're occurring, and if they're occurring, what devices they're occurring on. And then the last one was around crash looping and a number of other crash states. The other one is we're also looking at the OS side. Not to say that everything is about apps. It's not. We do have to bring a level of sanity and attribution to the operating system. One good example of that was the improvements we made in boot time and really looking hard at how the OS is structured. And the other one is also going to be starting looking at I/O throughput. How many scans are happening in the background and different parameters. And all these things will start coming out and being available for you guys over the coming years. So just to give you an example of this, I have a selection of Google apps. I have hidden the names to protect the innocent/guilty. But what I have put up there is a hash line, and the hash line is effectively the threshold that you're going to see of when we say an application has crossed into the territory of bad behavior. So you can see the majority of applications in this cross-section, and these are all major Google apps. Most of them are quite good, and there's a few outliers that are having issues where a wake lock is getting stuck in their applications. And you can see the percentages here. Like, they look small, but when you see these numbers of like 0.5% here, 1% there, those are just one app. And as I mentioned before, only one app needs to make this mistake for your entire device to suffer. Multiply that by the 100 apps. If you work out the ratio, you're going to have a bad time. The next one here was talking about foreground crashes and helping our developers understand repeat crashes, repeat offenders, rapid crashing in a cycle. We generally had good instrumentation to help developers understand if you crash, but not necessarily the severity of repeated crashes versus sporadic crashes. Do I have a population of 5% crashing really extremely, or is it really spread across a population of 95%? And the very last one here is about frozen frames. And you can see another example of most applications are actually doing pretty good. And in this case, there was one who was a little not as good. And when we pass this data along to the team, they're like, crap. Not their intent, obviously. But it really makes the experience of the device not really that fantastic, especially their application. And it makes the users wonder, like, is my device wrong? Is the app bad? What's happening? So giving this information back to developers, then they're able to start remedying these problems and solving them. So the big thing here is visibility. And this is visibility both for you guys as well as for the user on their device. So new developer tools. We're also doing a lot of outreach, both internally and externally with BizDev to reach out to teams and inform them, hey, do you know this is happening on your apps? And in many cases, we don't, and it's a quick fix, and especially when it comes to wake locks. It's usually a fairly straightforward fix once you know which wake lock is the one that's been stuck. And the last one here is battery settings in the Play Store. I'll talk a little bit about that. And then OEM dashboards, is we also want to get this data over to OEMs so they can see what's going on. And they can make sure that devices are intrinsically good and that you have a strong base to work on, that you're not seeing jank because of the device freaking out, but you're having a good experience, and that you have the ability to control your own destiny. So battery menu on here is about this is the new O battery menu, and it was redesigned with the idea of being actionable for users. We wanted to make sure that if you go to this menu, you don't go, okay, I see Google Play Services, the settings, Android OS, and the screen. And you're like, what am I supposed to think if I see this? There's really nothing actionable here. And while it was technically accurate, it wasn't necessarily useful to what you're trying to do, is to understand what applications are impacting your battery life. So this is how we restructured it. And we also included, though, your foreground interaction with those applications. And this is something that happens really quite commonly. And I'll give you just a quick anecdote from internally. I had a bug filed to me, and it was about Android O battery life. It's horrible. I don't make it past 3 o'clock. What's going on? And dig into their bug report, look at what's going on. And what happened on their device was they were playing Pokemon Go for 2 hours on Thursday at 1 p.m. And my reply was like, that's pretty amazing that you got this much battery life out of Pokemon Go on your phone. Also, it was Thursday at 1 p.m., Googler. But the thing was that I took away was they didn't realize they played it that long. And so that was happening quite often. You'd see an app be high battery drain, but you don't necessarily recognize, oh, it was because I used my phone like an extra hour today. And it's hard to remember how long did I really have the screen on. And so that's how we really structured batteries, to help inform you of how long you're using the device, how long you're using different applications, and so that you can make this comparison of what is happening in the apps. We don't want to pass judgment on an application being good or bad. It's not necessarily a bad thing if an app uses 20% of your battery. If you were live streaming an event, that's pretty decent, especially if it was for an hour or two. So we're not trying to say intrinsically things are bad if they're high, but we do want to add some visibility so that if a user can see, this is an app I didn't engage with for days. Why is it taking up 5% of my battery? And then those questions can start happening on the user's part and giving you guys feedback, and then you can see the same data in the Play console. So this is where I will transition to talking a little bit about the future, so you can kind of get an idea of where we're going. This is also my suggestion to really look at background limits, to look at targeting O, to transitioning away from background services to jobs, alarms, GCM, et cetera. And the thing is, we want to get to this amazing battery life that I started out with, multi-day battery life. And to do that, there's a few things we're going to have to change, if you will. But I want to talk about some principles. One is we fundamentally believe applications should be able to run in the background. We want much more well-defined rules about when applications are able to run. Today, you can see a number of OEMs taking strategies trying to solve this problem independently. And it becomes really difficult for developers to deal with that world when you don't necessarily know what the rules are. So we want to get a lot crisper there. We also want users to better understand battery impact. You could argue my previous statements about the settings menu was like what the user has to do math in their head about how much time that it used and how much battery it used. And I agree with you completely. We want to get to a better place where it's much easier for a user to understand what's happening. And we want to then enable a user who says, I'm not OK with this. And if the application doesn't offer the control, to give them another option than uninstalling the application, something other than just the nuclear option. And then the last one is we really want this idea of consistent device performance, that you shouldn't be worrying, will my device make it through the day today or not? Will it be able to make it till I get home on charger? We want that to be something reliable. One of the, all these use cases that we're doing on phones and all the properties from Google and all the properties that you're making as app developers, you can't really rely on this stuff unless you know your phone's going to be there. And so that's really the underpinning for this general strategy. And so how do we get there? So there's three kind of big tiers. Is we have to consider what is the API contract. We don't want to break the promises we make to you. However, we do make a lot of promises that we later regret. And so an example of this is a wake lock. If you were to generally describe a wake lock, you're saying, we've given the application, any application can tell the OS, stay awake until I say to go to sleep indefinitely. And when you give that level of control and there's not really a way to close the loop, you end up with varying battery life. And so we have to figure out then what is the right promise to make to a developer? And what is the range of that promise that we should be giving to enable the use cases, but make sure that the OS can be responsive in the face of adversity or many applications taking advantage of the promise that's being made. The other one is that attribution that I mentioned before and the controls so that the user can then take advantage of this stuff. And together, the three of these things should give us a much better structure. And so this is all of this is, again, like you see this little exciting badge about pending review on there. These are really just ideas to articulate how we're approaching the problem because we know it's a big change. And so we're trying to broadcast this change really early so you can take advantage of it. You can start moving over to background limits and targeting O now so that you're not going to have a bad time later on. And so some of these things is we need to look at more limits on background scanning. We have to adjust the limits that we're doing. We haven't really gotten around to Bluetooth yet. We're also looking at applications listening to other events on the device and whether those things should be happening or not. The big one here is deferring work. We want the OS to have more flexibility to have discretion about when jobs run. When it's all services-based, the OS has really no control. If a single large install-based application makes a unilateral decision to increase its wake lock time, the OS today and the user is powerless to do anything about it. And so that's why we're looking to make these transitions. And the balance should be now users are more in the driver's seat about what features the application is giving and whether the user finds value in those features running in the background, and then they can articulate that. The default for all these things is on, and the model you can roughly think of as long as you're cool, the OS will be cool, and everybody will be cool, and it's great. If in this scenario, though, applications start getting aggressive, battery starts getting high, scanning rates start getting higher, we may start informing the user, hey, this stuff's kind of heavy on your battery. Do you want it to run in the background? And then they can articulate that back to the OS. And then we can begin having a control surface for how we manage individual applications. And so then the user can say, these 10 apps I care about a lot. These other apps, not so much. We're not suggesting that we need to have a micromanaging menu. That's not the desire. But using things like how users are interacting with the application. How often are they interacting with GCM messages when the application gets woken up? How often do they interact with notifications? These are all great signals to inform how the OS should dole out its limited resources, namely battery. And the last one is we have to beef up the idea of foreground service and figure out how does that as an API surface and how does that as a UI construct not turn into all the applications rushing to the exits of foreground service, and then we're back in the same mess that we are now with no control surface again. And we want to find a balance so that applications can generally do everything they need, and that in the extremes, the user is able to articulate approval for these extreme situations. And we're hoping that that's going to result in a much more stable, much more reliable device in the long run. And so hopefully that gives you a bit of insight about how we're approaching Android health and mostly battery life and resource contention. So, I forgot a slide. But the idea here, the last one was attribution and value. And so we want to really make that identified. I already talked about the points. I won't bore you repeating it. And thank you very much for your time. Thanks.